first, live, local. This is Fox 12 Now.
Hello, everyone. This is Fox 12 Now. Thanks for joining us. I'm Greg Nibbler. We are live streaming here out of the Fox 12 Oregon newsroom. We're here every weekday. We start at 1 p.m. We go throughout the afternoon. We cover a wide range of topics. I always like to remind everybody of that, whether it's breaking news or very fascinating discussions about research is what we're going to be doing right now from Oregon State University regarding some new research associated with Alzheimer's. And we want to get into the findings from this. You do not want me to attempt to explain this. Instead, we have one of the lead researchers joining us right now, a much better expert for that, Marilyn Rampersad. Thank you so much for being here with us, and really appreciate your time on this. And I'm excited to talk about this. Obviously, something that could have Alzheimer's affects so many people. And before we get into that, wanted to know just maybe a little bit about yourself and your role there at Oregon State University.
Thanks for having me on, Greg. I'm a professor in chemistry in the department at Oregon State University, and my research focuses on understanding chemical processes that contribute to diseases such as Alzheimer's as well as cancer. My lab focuses on materials development, so we make a variety of nanomaterials for diagnosis, for drug delivery, but one of the things that we also focus on are fluorescence-based techniques to observe disease processes at the molecular level so we can better understand how the disease develops and how it might be treated.
When it comes to Alzheimer's, would you mind, just to give everybody a bit of an overview of how much this disease affects people, or just to understand a little bit more about Alzheimer's disease from a top level itself?
So Alzheimer's disease is a progressive brain disease that affects memory and thinking, and eventually it affects a person's ability to carry out everyday activities. It occurs when proteins in the brain misfold and clump, damaging and eventually killing healthy brain cells. These changes can begin many years before symptoms begin to appear. One important factor that triggers the clumping in the brain between proteins is the protein itself can interact with itself, or metal ions that are found in high concentrations in the brain, such as copper, can interact with these proteins and cause them to clump, which is one of the processes that our research is trying to help better understand.
So that clumping, that's where the real damage is occurring.
It is. That's one of the mechanisms. Alzheimer's is very multifactorial, meaning there are a lot of different things that are happening, but the main dominating hypothesis is this protein interaction with itself or with metal ions.
So when it comes to this study in particular, can you give us, again, I keep going to the overview of it, but really to give everybody a basic understanding, can you talk about the overview of this study and how it in particular came about?
Well, we wanted to study exactly how this copper metal affects Alzheimer's related proteins and whether that harmful process could be reversed. So to do that, we developed a simple fluorescence-based method that allows us to watch the molecular changes in real time using light. This is incredibly important because Alzheimer's disease affects over more than 6 million Americans, and it costs about $300 billion each year in just patient care alone. So it's a major scientific and medical challenge, and trying to understand the chemistry behind disease is a critical step towards developing better treatments. For the first time in our lab, we were able to directly watch the harmful protein clumping associated with Alzheimer's disease using a fluorescence-based technique, which works like a glowing signal. Even more importantly, we show that if we could remove the copper from its interaction with the protein, we can reverse the process of clumping that we see.
Wow.
And we're interested. Go ahead.
Sorry. I'm sorry. That's amazing. So you were able to potentially reverse that clumping?
Yes, we were able to reverse the clumping when we introduced a small molecule that would bind to the copper and remove it from the protein.
Wow, that's incredible. And so this is the research, that you're working on this. I just want to ask, from a personal standpoint, what was it like when you put so much time into this research and to actually see that take place?
It's very exciting. I think it helps us to think about what other small molecules could play a role in reversing protein aggregation inside of the brain. And I think it's an incredibly important thing for other scientists that are working in the same area. to be able to see this reversal. So it's very exciting for us. I think research like ours, where we show copper can play a role in triggering this harmful protein clumping, when copper interacts with these proteins to cause them to stick and it can be removed, that's huge therapeutic potential.
Yeah, and is this something that, and I want to talk more about the Alzheimer's side of things too, but you mentioned, other research. Is this something that can be translated into other research that's going on?
Yes, I definitely think so. I think our work is just an early stage where we can look at the protein aggregation and the information we get from the technique, the fluorescence-based technique, will allow other people to develop therapeutic strategies. So it's not just something that we can do in my lab. I think other people can use that information to enhance scientific discovery towards therapeutic development. This fluorescence-based technique allows us to look at this chemical process that normally is invisible, and it gives off a light when the signal changes as the proteins clump together and when they're separate. So this process that we're allowed to see using light is in real time. So it's like turning on a light to watch something that was previously invisible and then finding a way to stop it. And I think that's incredibly important for other researchers.
That's amazing. Can you tell me, I know, I'm sure it's very complicated, but just you gave a brief overview there of how this process works, utilizing the light. What is unique about this that you didn't have access to before?
I think one of the things that we have been able to do is using this light-based techniques, we could look at molecular level changes with very small concentrations of the proteins compared to other techniques that have been used by other researchers in the literature. So we don't have to wait for a lot of protein aggregation to be visible. We can see these things when a few of the proteins start aggregating with the copper. And it's very sensitive to changes. So if you had a single protein by itself, you wouldn't be able to see too much changes. But when the protein interacts, because of the copper, we can see huge changes in signal intensity, which is a very sensitive technique.
Wow. And now that you've discovered this, as far as where you're at with this research, what comes next with the research here, and what are the potentials for any kind of a treatment or something associated with Alzheimer's disease?
I think for my lab, this is an early step in understanding the disease at a much deeper level and trying to figure out how copper drives this harmful protein complex clumping. But then at the same time, we're able to use small molecules from our research and other people's research to develop a better idea of how the small molecules can reverse the process for future treatments. So I think it'll open a lot of research opportunities for other scientists to look at small molecules that they might have in their lab to be able to identify which one's going to be a good target for future treatments.
So this could really open up a lot of possibilities for a lot of different studies associated with diseases or really a number of different things, it sounds like.
Right. And the nice thing about this technique is that you can modify it in a way that you can screen hundreds of small molecules that already exist. You might not have to develop a whole new molecule to target the protein. There are existing current therapeutic drugs that could be used to reverse this process, whether it's copper-based or the proteins interacting with themselves.
Amazing. This may be too much to ask. Obviously, this is just research at the very beginning, but when you say reverse clumping, does that mean possibly down the line, this is something that could reverse the process of Alzheimer's?
I think it definitely could slow the process of protein aggregation and cell death. I don't think it'll be able to reverse some of the damage that's already done, because when the proteins clump and they interact with healthy cells, those cells die. So you'd have to be able to find a way to replace cells and reconfigure a memory that way. But you can definitely use, if you can catch the disease early in its phase, you can slow the process down or even preventing the disease progression from happening.
Wow, amazing research. So now, again, just to go back to where we are right now, what comes next for you?
What comes next for us is we're going to try and continue to develop this process and to look at other small molecules. Obviously, we've just looked at one molecule so far, but if we can develop better targets for this copper-related process, then we can help translate our discovery into strategies that can help slow or prevent disease progression from happening.
Wow. And Marilyn, last question. What do you think is the most important thing that the general public should know about the research that you've done here, both with this and just in general at Oregon State University?
Well, obviously, this research was going to continue in my lab and other researchers' lab. We do know that maintaining brain health is incredibly important. So good physical activity, good nutrition, sleep is incredibly important. I tell my students this all the time in my class when I'm teaching, that sleep is incredibly important. And then managing good cardiovascular disease or good vascular health is incredibly important for reducing health. While we think of a new scientific discoveries that can help us or give us hope for better solutions in the future to reverse the disease progression.
Wow. Well, thank you so much, for joining us here on Fox 12 Now, just to talk through what it is that you've been doing there and what this research could potentially mean and has already accomplished. For people out there who want to follow along or find out more, go more in depth into this study, what's the best way for them to do that?
They can look on Google. It's a great resource, certainly my website. And we also try to highlight the research that we're doing. Oregon Health and Science University has an amazing team of researchers that I've interacted with over the years that are doing incredible work in this area. So follow us along on social media. And if anybody has any questions, they could look me up and ask me questions by email.
All right. Well, thank you so much for joining us, and talking to us and answering some of these questions that I had. I appreciate you making this easy to understand and to translate, this incredibly important work that you're doing for everybody to really grasp what's going on there. So thank you and congratulations on this, and really excited to see where you go next.
Thank you, Greg. Thanks for having me on, and happy to chat again in the future.
Absolutely. All right, and for everybody watching, we're going to go ahead and sign off for right now. If there's breaking news that happens between now and 4 p.m., we'll be back with that. And you never know, anytime there's a possibility we could be going on. So thanks for joining us. We will sign off for right now, though. I'm Greg Nibbler. This is Fox 12 Now.